Hey guys, so today we're going to look at how electricians read and draw circuits, all right? So we're going to be drawing something called a schematic, which is an electrician's diagram. And we're going to compare that to just drawing or taking pictures of circuits. So if I gave you a photograph of a circuit, basically how would you be able to draw the schematic is what we should be able to do by the end of this video, all right? So the definition of schematic, it's an electrician's drawing of a circuit using symbols to represent various parts. So there's some official symbols we need to learn that are in this hieroglyphics here on the left side of the page. Well, that is a circuit schematic, all right? So what do all those symbols mean? Let's start with these squiggly lines here. What are those? Those are resistors. You might say, what is a resistor? What then? It's an object that you plug in which uses energy. So an example would be a computer, a lamp, a TV, really anything you plug into your wall is a resistor, all right? It means it has resistance and it uses energy. All right, so our next symbol is right here on the left side. That's our battery symbol, okay? The long line on the top is one terminal, and then there's a space and a short line on the bottom, and that is another terminal. So it goes basically, the symbol for a battery goes wire in, long line, space, short line, wire out. And battery just stores energy. It provides energy to the circuit, all right? Then we have two symbols for switches, one closed and one open. A closed switch looks like this, dot connected to another dot. And that means it conducts electricity when the circuit is closed. An open switch would be when all the lights are off, all right? And you can see that that line is not connected. It means it doesn't conduct electricity. And I drew those in our circuit diagram over here. We have closed switch and open switch, all right? Now, we're going to look at two types of circuits and draw schematics for each of those. First, we're going to start with a series circuit. So a series circuit is where there is one path for the electrons to go. The electrons could only go forward or backwards on the same, it's like a one-lane highway, basically. There's only one way to go. And because there's only one way to go, an electron has to pass through all the bulbs, all right? So an electron's going to start off here. I'll make a little dot on our picture of a two-bulb series circuit, and it's got to go through both bulbs to get back to the other side of the battery, all right? So we're going to talk about what electrons do is they go from one side of the battery to the other, all right? And they have to go through bulbs to get from one side of the battery to the other, all right? Now, do they have to go through all the bulbs? Well, in this case, to get from one side of the battery to the other, they have to go through both bulbs, all right? So a 3-bulb series circuit, you could pause at any time and make this chart for yourself. A 3-bulb series circuit, to get from one side of the battery to the other, no matter what, the electron has to go through all the bulbs, all right? Because there's only one path. So what would a schematic look like for these circuits? For the 2-bulb series circuit, you got your battery on the left side. There's your battery symbol. And you got two squiggly lines, one for each of the bulbs. And you can see that there is only one path to go, all right? It basically looks like a square, all right? We don't really draw circles in our schematics. We draw it as squares, okay? Now for the 3-bulb circuit, the only difference is you add one more squiggly line, but it's still one path. There's only one way to go on that one-lane highway for a series circuit, all right? But now we're going to look at a parallel circuit, which is a little different. So you're going to redraw this same table, 3 rows, 3 columns. Parallel means side by side, basically, all right? That means the electrons can choose their path to go, because there's going to be multiple paths this time. So series circuit, before there was only one path. Now parallel, there's going to be more than one path. So let's start with our little drawing of the battery. This is my picture. It's not my schematic, so it's just going to be my artistic rendition here. All right, and for two bulbs, our first bulb is going to look like this. Now, how do you think for a parallel circuit, how do you think that the second bulb is going to be connected? All right, it's not one after the other. That's what series circuit is, one after the other. Parallel is side by side. So that means I'm going to have a wire come out of the first bulb and to go to the second. So if you're an electron here, let's draw them as a person, you can choose to go like this back to the battery and just go through one bulb. Or you can dance on these wires and skip over the first bulb and go to the second bulb and back to the battery. So an electron gets to choose which bulb it goes to in a parallel circuit. It can go through the first bulb and back to the battery, or it can go to the second bulb and back to the battery, but it doesn't have to go through both bulbs. And really, an electron will choose just one bulb to do it with, all right? So electrons can choose their path. There's the first bulb path and the second bulb path, all right? In each parallel circuit has multiple paths, all right? So an electron is going to choose less bulbs to go through. It's only going to choose one of these, basically, to go through. All right, what would this look like in a schematic? Well, let's start with our battery, long line, short line, like that. And then you'll have your first bulb like this, all right? Now, in a series circuit, remember, you had to go through this first bulb. To get to the second bulb, you had to go through the first bulb to get to the second bulb. But here, we're going to show you don't have to go through the first bulb to get to the second bulb, because in parallel, they're side by side. The bulbs are side by side. So you could go to the first bulb and back to the battery, or you could skip over the first bulb, go to the second and back to the battery. All right, so for three bulbs, it looks very similar. You have your first bulb just like we drew it before. Your second bulb right side by side again, just like we drew it before, and you could just draw another bulb side by side, and that would be your picture for a 3-bulb parallel circuit. And for the schematic, again, it would look very similar, but we would add just another bulb. Not here, no. We would add it side by side, so you don't have to go through any of the other bulbs to get to the third bulb. To get to the third bulb, you could just skip all the way down here if you're an electron and go back to the battery. You don't have to touch these, all right? So in a series circuit, you got to go through all the bulbs to get back to the battery. And in a parallel circuit, you can choose one of them to go through before you go back to the battery, because the bulbs are not in a line. In the parallel circuit, they are side by side, all right? So you should know how to draw your schematics. If I give you one of these pictures, you should be able to recognize, okay, if I give you any of these pictures, that is a series circuit, and you have to go through all the bulbs. And if I give you any of these pictures with the bulbs side by side, that is a parallel circuit, and you do not have to go through all the bulbs to get back to the battery. You just go through one of them, and you get to choose which one.